Okay, so exponent laws, variable bases. You've done a lot in junior high with exponent laws with number bases, and so this is just an extension of that. So rules that you should know. Um, we have a chart as well that you may have gone through or will go through in the next video. Depending on what order. So here, multiplying powers with the same base, they're both bases are a. Remember, you add the exponent. So that's going to be a to the 5. Dividing powers with the same base, you subtract the exponent. So the base is a, and you subtract. Base always stays the same. A squared cubed is going to be a to the 6. You multiply. Okay, and then power of a product, the 4 applies to each factor in that bracket. Okay, so really you're not going to change the a. In junior high, you may have had difficulties a little bit if you had something like 5 cubed times 5 to the 4th. Some students will say, oh, that's 25 to the 7. They know to add, but then they multiply the bases. Think about what powers mean. It means a repeated multiplication of 5. So that would be 5 3s multiplied by 3 5s multiplied by 4 5s. So in total you have 7 5s. Okay, so just remember that. With variables, actually, students tend to make fewer mistakes. Okay, power of a quotient, 3, as long as the brackets are around the whole thing, then the 3 applies to the whole thing, each part. If it was just a cubed over, if it was something like this, a cubed over b, that's different. That would just be a cubed over b. Okay, so different from that. This one, notice, this is different from something like this. This was a product in the brackets. This is a sum. So for sum or difference, that's where you actually have to show it the long way. Well, you don't actually have, there's a fast way of doing this, but that's really what that means. And so think about back to the polynomials unit, you have to use the distributive property, which some of you may abbreviate with the word FOIL. In any case, you'll end up getting a squared plus ab plus ab plus b squared, and you collect like terms. So hopefully most of you are now able to go right from this to this, knowing that when you're squaring a binomial, it's the first term squared, it's double the product of the two terms, and the last term squared. But this is really the meaning behind it, those two factors. So do not get this mixed up with this, right? If you give me a squared plus b squared, yikers, okay? It's not uncommon for students to do that, but it's wrong. You're missing that middle term. So be very careful. Okay, negative exponents. So it says simplify the following using 2 different methods. So one method, I'm going to go back to the basics. A times a is a squared. A times a times a times a, 4, 5, 6, 7 in the denominator. And then divide out that a, divide out that a. So what you're left with is 1 over, there's 5 a's in the denominator. Okay, another way is we can use the quotient rule where you subtract the exponents. So 2 minus 7 is negative 5. Okay, that means these are equal to each other. If you've done the exponent laws table, then we've already gone through this. But if you have a negative exponent, most times we're going to ask you to show it as a positive, which means you have to take the reciprocal or invert the base to the denominator. Okay, so a to the negative 5 is really 1 over a to the positive 5. So here, a to the negative n is 1 over a to the positive n, as long as a is not 0. Okay, now what if you have a fraction to start? So here, the process is, this is really a is a over 1. And so if you think about this, a over 1 to the negative 5, if we take the reciprocal, then we get 1 over a to the 5. We just never show this step, but the 1 to the 5th is always going to be 1. So here, though, it's a fraction. So we need to take the reciprocal, and anytime you take the reciprocal of the base, it changes the sign of the exponent. So now we have an exponent of positive 2, and we can evaluate that. That's going to be 25 over 16. Okay. Next one, actually, I'm going to show you on your calculator. So here, if you were to do this on your calculator, you need brackets, and then 4 divided by 5, close bracket, to the exponent negative 2. Okay, it'll give you a decimal. This is a fraction. If it starts with a fraction, you got to give a fraction. Now, you can convert that, math frac, without doing too much mental math, but in case we give you a test that has part without a calculator, you got to be able to do this without a calculator. Okay, so next one, and most times it'll actually be in terms of variables, so your calculator won't do it anyway. So this is to the negative 5, so we need to take the reciprocal, positive 5, and then just get rid of the brackets. So y to the 5th over x to the 5th. All right, so that is negative exponents. To summarize, with a fraction there, we want to flip it and change the sign. And so both a and b cannot be 0. Okay, it just doesn't make sense for this. All right, so last thing, putting it together. So simplify means reduce as much as possible, no negative exponents. Okay, so if we say express in simplest form, and you have a negative exponent in your answer, you haven't finished it, and you'll lose a half a mark or a mark depending on the question. So simplify means no negative exponents. Remember that. Sometimes we'll remind you, but sometimes we won't. So sometimes there's you can kind of do it in a slightly different order and still get the same result. In any case, so here I could go 7 to the negative 3 and then x squared to the negative 3. Because these are both positive exponents, that's 7 to the 1, right, and x squared, I'm going to deal with this negative and make it positive first. So I'm going to go 1 over the bracket. And then that's going to be to the positive 3. Okay, so then I simplified that denominator. So it's going to be 1 over, and then 7 to the exponent 3 is 343. And x squared cubed is x to the 6th. Okay, and remember x can't be 0. So that's how I would do that one. Next one, take a look. Can you simplify anything in the brackets? No. So then the whole thing is raised to the exponent negative 4. Before expressing each numerator and denominator to negative 4, because the whole thing is raised to a negative, I'm going to flip it to make it positive. So take the reciprocal, will be 8b squared over 3a to the positive 4. Okay, now everything in there gets raised to the exponent 4. So 8 to the exponent 4, b to the 8, over 3 to the exponent 4, a to the 4th, and then evaluate 8 to the 4th. Now, if you don't want to show 8 to the fourth there, that's totally fine. I'm just doing that so that I know you're not going to forget about raising it to that exponent. 3 to the fourth is 81. Okay, I've got positive exponents. Nothing can reduce. I know that just from back here. 3 doesn't go into 8, no common factors, so I'm done. Okay, and again, A and B cannot be. So A and B cannot be 0. All right, next one is, there's a few things to do. So it's one fraction. So we need to figure out the numerator first because it's a couple of powers and a multiplication. So if you think about order of operations, brackets is first, nothing to do inside the brackets. Then exponents, lots of exponents. So the first will be x to the 6. The second, now here, notice how it's 2x cubed all to the negative 3. So you could raise 2 to the negative 3 and x to the x cubed to the negative 3, or you could take that whole bracket and to make it a positive exponent, put it in the denominator. So that's what I'm going to do. I'm going to leave x to the 6 up top, over top of, and then bringing that down would be, so 2x cubed will be to the positive 3, and then 4x all squared, which I could have simplified a little bit, but we'll take a few steps here. Okay, so that's going to be x to the 6. Then 2x cubed cubed. Well, that's 2 cubed is 8. X to the 9. 4x squared will be 4 squared is 16. X squared. Now what you could do is simplify the denominator and then divide out, or you could divide out now. We know that x to the 6 will leave you with x cubed in the denominator, or hopefully you know that. So again, a few different ways of doing this, but this means you've got 6 x's up top multiplied together. This you have 9. So all 6 of those are going to divide out with 6 from here, leaving you with 3 of them. So then this is going to be 1 over 8 times 16 is 128. X cubed times x to the x squared is x to the 5th. Now, if you, I'm going to extend this down. So if here you, instead of dividing out like I did, you said x to the 6 equals 128 x to the 11, then maybe you subtract it. So you'd get the exponent, so you get x to the negative 5 over 128. Then you would have to bring that down to the denominator, which leaves a 1 in the numerator and makes that exponent positive. So this is 4. Okay. Next one. Okay, so what are we doing here? We've got some two fractions, x's in both numerator and denominator, and y. So I'm going to simplify this as much as I can. Nothing to simplify within that. So I'm going to just rewrite this. So 24x cubed y to the negative 3 over 6x to the negative 5 y cubed times x over y to the negative 5. Okay, so within that first fraction, 6 goes into 24 4 times. You do not subtract, it's not 18. Then the powers here, well, 3 minus negative 5 is 8. Okay, so remember when you're dividing powers with the same base, you subtract the exponents. If you're subtracting a negative, it's like adding. Then y to the negative 3 dividing by y to the positive 3, you subtract. So that'll be y to the negative 6. So this ends up being positive. Y exponent is negative times x over y to the negative 5. You can show this over 1 if you want, but it doesn't really matter. Now, you can multiply through and then simplify, or simplify the y's first. I'll maybe multiply through, so 4x to the 9, y to the negative 6, over y to the negative 5. So now, nothing to simplify with the 4 or the x. For dividing these powers, negative 6 minus negative 5, that's like adding 5. So negative 6 plus 5 is negative 1. But I'm still not done because I have a negative exponent. So the 4x to the 9 stays, and to make that a positive exponent, it has to go to the denominator. And I don't need to show a positive 1. Okay. Again, you could have done this in slightly different order of steps because it's all multiplying and dividing, but you should end up with this as your final answer. Okay, and then the last one here, I'm just going to copy it out again. So 8m cubed n to the negative 3, 4m to the negative 2n, negative 4. Okay, so a couple of things. Within the brackets, we can simplify and then deal with the negative 4. Or you can deal with the negative 4 by flipping this and then simplify. What else? You could take everything in here and raise it to the exponent negative 4 and then simplify. So a few different choices. I think what I might do is inside the brackets to follow the order of operations. So 4 goes into 8 twice. M cubed divided by m to the negative 2. Well, you're subtracting a negative, which is like adding. And then n to the negative 3 divided by n to the 1 is negative 4. Okay, and then now, to make that positive, I'm going to go 1 over 2m to the 5th, n to the negative 4 to the positive 4. And then simplify that. So 2 to the positive 4 is 16. M to the 5th to the exponent 4 is m to the 20. And then this will be n to the negative 16. So notice, not simplified because we have a negative exponent, but the negative exponent is in the denominator. To make it positive, you have to flip it. So that's going to be n to the positive 16. But the 16m to the 20 stays in the denominator. Okay. So again, you could have done it slightly different ways, but you should all end up with the same answer. And that's it.